Like I know that concern when we can read it like and then students can have
Yeah, it was like half the price of like the computer, like my MacBook when I got it in 2022. Like this is like half the price of it now. It was like this, it was like the same MacBook, the Air version. Like, yeah, that's a good thing as well. And how is that double the price of 3 years ago?
like that kind of like the one with the first line. I have to see what kind of right. So it was we were at the beginning of it, just have to because it's like we need to find out in conference and they do something. And it's like they don't.
Everybody doing? Good. Palm. Palm's good. Or yeah. Now I'm getting. All right. So last time we got basically through this bit, right? Is that correct?
When we installed
We installed CKit.
they just installed.
Okay, right. So we learned to use parameter expansion inside of the loop. And then we installed CKit, put it in our path. And then we can run it using a wildcard. So here it's just CKit stats is the command. Once it's in your path, you should be able to say that from anywhere in Bora. And then star.fastq.gz, that'll be any files where you are. Begin with whatever, and end with .fastq.gz. If I go in here to Bora, I'll do my biocomputing lesson 5. Okay. I've got my data. You all have all your chopped FASTQ files in there. Okay. So seek kit stats star dot fast q dot gz.
I don't know, they don't have that dot.
Oh, they don't have a dot gz.
What is the dot?
Gzipped.
Oh.
So compressed. Those are my initials also, and I always forget. My students think that that's like my custom file.
That's what I was wondering.
Yeah, no, it's yeah, so that's a standard. So I don't want .gz because really they're not gzip. So oops, what did I do? Put the slash, and so it's thinking that I'm continuing my command. That backslash means new line, waiting for command. Control C. Try this one more time.
There we go. And I'll change this here. Lesson. Okay. So pretty straightforward. Somebody's nice bioinformatics toolkit here called SeqKit. And one of the commands that SeqKit allows you to do is stats. This kind of works like Git, where you invoke the command and then there's a subcommand like git add git commit. This is SeqKit stats. I've noticed a trend in bioinformatics tools that a lot of them are moving towards this kind of subcommand thing. I like it. Yes,
So what do you mean by using a wildcard?
that's this.
Yeah.
Yeah, so the wildcard is, I'm basically saying like, hey, I'm in my lesson 5 data directory, and so I see a bunch of FASTQ files here.
Mhm.
I want to do something on all of the files here that start with whatever and end with .fastq. And CKit stats gives us, well, the stats table on all the files that we had. So I'm just looking at the top 3 here. Those are all the same sample, SO90. What's it telling us? This is our little sanity check for our interleave chop that we ran. But we don't just trust that it worked right. Here we are checking. What are we looking at that I like?
Just taking like the top 10 or last 10 sequences, and I'll explain the whole narrative.
The original was 2 files, read 1 and read 2. Chopped one is the new one.
You got like 200. Oh, just like what we said.
Yeah, we told it to get rid of 200 nucleotides. And it seems to have. Yeah, and the total number of sequences, because forward and reverse, they each had 10. So now it's interleaved. So all 20 of them are present in that final file. And they're all much shorter.
What is the connection between like the 3010 and the 3 and like the 2000 like I don't know.
Some len. So I'm thinking this is the total length.
Like of like the file or
Nucleotides, right? So we've got 10 sequences here.
Mhm.
The minimum length is 301, the average length is 301. So they all have 301 nucleotides.
Oh, okay.
There we have 10 times 301.
Oh, okay, so like so for each of the sequences, so 10 in like the R1, they're each 301 because you cut.
That's the
Or no,
original
that's the
length.
original. And then in the chopped, that they are all like 101, and then like 101 times 20 gets like the sum of the length.
Totally.
Okay. Is this like always the case where like the min, average, and max will be the same or no?
Now,
Oh.
I'm giving you nice data right now. Especially curated.
So then if like these are different, how would you arrive at like the sum length where you can't really do that without like looking at?
You have to look at the file.
Okay.
Yeah, I'm like, I don't use SeqKit very often. I picked it because it was super easy to install. And so I'm guessing that to get some len here, that they actually just count up all the nucleotides present in the whole file. Here we can see that they kind of make sense. Okay. Well, here's this. Let's go back through and see what we did here. All told, We ran interleave chop on all of our files in a nice little for loop in our fancy parameter expansion. Okay. Then we installed the tool, added it to our path, made it executable, all that good stuff. And then we ran that tool on those files to check. Well, that's a pipeline. We've done it. Well, sort of. We did it in little pieces scattered around over the course of the week or whatever, but we did it. And so we downloaded an external tool, unpacked it, added it to the path, ran it on a series of files, and used a local bash script and a for loop. All that together were just basically 3 steps of a pipeline.
Just like quick question to like go
Yeah.
back. So like I know we talked about it last time, but like during the assignment we had to like physically like add the half of this to like to like the bachelor seat. For last class, didn't we installed it right into programs because programs is already in our path. That's
Yes.
why it worked.
But careful
Yeah.
with that. So here's the thing. Let me show you my my programs.
Mhm.
Yeah, seek kit is right there. And so I don't need to really add it to the path since programs is already in my path.
Mhm.
Happy with that. But I've got seek TK. That's not going to show up in my path because it's a subdirectory inside of programs. So if I want seek TK, I actually have to add programs/seek TK to my path. It's only then can it find the executable file. So that's a bit tricky. If you put it into programs, yeah, it might work if the executable file just lives there. SeekKit does that, but a lot of other stuff that I'm installing makes its own subdirectory. And so I need to add each of those subdirectories to my path also. Yeah,
Would CTK not work if you copied it and put it in your programs? Cause I know that it's its own subdirectory, but I guess theoretically what happened if I copied the script and just put it in the programs?
with this one, yeah,
Okay.
it will. A lot of other tools that we download, like Fly here. This is for assembling genomes. It's got its own separate binaries folder, and that's where Fly actually lives. And that needs to live there because it needs to know how to access lib and source. And so Fly, for example, actually has to be in its own directory. And if I just copy the Fly executable here into programs, it won't work. Because it won't have that relative path to get into the libraries. So SeekTK is, I would say it's in the minority of programs that it's just like a file. You can move that anywhere and run that.
You mean the seat kit?
SeekKit, not that, yep. It's more common to have it kind of like this. Where, and this is kind of confusing, but the actual executable for Fly is in programs Fly bin. And so that's what has to go in my path in order to access this.
Oh, so you have to go
You need
into the
to,
bin to get that, but you can like go out of that to like access the other stuff.
it knows how to go back one.
Okay.
Yeah. And this is real common with tools that you download from GitHub, especially because they come with their whole nested subdirectories, and the bin is the binaries. Those are your like executable files, usually. And they like will be accessing things using /lib. Yeah. So, yeah, tricky case, but in this case, SeekKit, it did just kind of unpack right there, and we can use it. Okay. Well, we've got a pipeline kind of in our heads and in our history and everything. So let's actually put it together and make a pipeline. And this is going to be a modular thing where we have 3 separate scripts. One is running, well, we'll have 4 scripts. One is the actual script, interleave chop that I gave you. And then you're going to write 3 scripts. One is to run interleave chop. The second script is to download and install seek-kit. And then the third script is to run seek-kit on all your interleave chop and raw files. So let me scroll down here. Well, of course, it's spread out over a couple pages. This is the pipeline I put together. And I'm saving this as lesson 5 pipeline.sha, but let's just look at it. Bang bin bash, set elio pipefail. Okay, those are just your standards. Then what am I doing?
What does that mean? Python.
So that was from the, you remember like the chapter 1 from Big Zero or whatever, in bioinformatics data skills. It's just a safety thing, and it's good to put at the top of your scripts. They'll run without it, but it's basically saying if any step of this pipeline breaks, we're going to exit and not run the next.
We just like
I just always include it, yeah,
and like any script.
any bash script. Okay. This one will work just fine without it. It's like safety. Imagine that your script is generating a bunch of files with names and something there breaks, and then it just moves to the next step in your script, and the errors just start cascading. And so this stops that. It just like shuts it down. All right, so I've got my little header prelim stuff, and then this next thing, what am I doing? The main dir, install dir, data dir, scripts dir. Yeah, I'm defining variables, and really there's only one I'd have to change. And that's the directions to my main directory. For me, that's in home biocomputing lessons 5. And then using that fancy parameter expansion, right? I can say the install directory is home programs. And then my data directory is my main dir, which is this /data. Where the scripts are going to be, it's the main directory /scripts. Why am I doing that up front?
You don't forget.
So I don't forget, and so I only have to change them in one spot. If I need to move this somewhere else, I only have to change this line. Because all these, these 2 at least, are built on that. And it saves me typing. I don't want to have to say CD all this stuff down here. I can just say, go into my data directory. Because we all have a different path to our home, right? It's like root, cyclone, users, your name, whatever. And so this will expand to whoever's home you're dealing with. Yeah.
For the running the script part, like, why don't you need the dot slash?
Where?
Like on the next step, the next line. Where you go up, or where it's like this, the a little bit like the echo running the script. Like, why don't you need to do Like when you run the first script, you don't need to do like,
dot slash.
dot slide.
I don't have to because I'm giving it the directory there. Remember what the dot means?
Yeah, it's just like that.
Here, it's just that
And just so
directory.
slash means running.
No, scripts here expands to root, cyclone, users, gzon. Right, and so that expands to my home / biocomputing lessons, lesson 5 scripts. And so to run a program, I'm just saying, here's where you find it. And that's, so far, we've just been saying dot the program because we've been there and we can
Yeah.
see it. You can run a program from anywhere if you give the absolute directory, the absolute path to it. Yeah. All right, so I'm defining those. I'm going to go into the data directory. And then this bit here, what's that for? The echo.
Same thing. Yeah.
Yeah, if this script breaks down and I haven't yet seen this pop up on the terminal, I know it broke before then. And this is just like a little progress message for the user. Then, yeah,
Sorry, is that the easiest way to track it? Just or something?
I like doing it that way. Now, one thing you'll see kind of often is sending the echoes to a log file so you don't have to sit and watch. You just have a log file at the end. Okay. Then I'm running chopfiles.show, which we haven't made yet. But essentially, it's just going to be its own little script that does the for loop that we did last time. And then I'm going into the install directory, my home programs. And I'm going to echo a little note to the user, and then I'm going to run from my scripts directory install seedkit, which we haven't written, but we've already done, so this shouldn't be too hard. Then I'm going to go to my data directory and actually run get stats, which we also haven't written. So those are our 3, and that's the pipeline. Okay. So why not just do this all in a single script? We could have our for loop run there, and then we could go into the install directory and install stuff, and then go to the scripts directory and run seedkit.
So like these kind of like use cases are like these, like at least like in this specific pipeline, they're just mostly just like downloading and like packaging stuff, or is it more like,
Well, only one of these scripts does any downloading. That's the install seedkit.
is it like common to like set up like have a script up as we go through downloading something, setting it up and automatically running something?
Yeah, but I mean, this is very common. This is like considered best practice, and it's called modular coding. But why is it a best practice? We could put all of our commands in this one script, but instead we're taking them and splitting them up into 3 separate scripts that live somewhere else, and then calling those scripts. It seems like a bit annoying to do that.
Maybe it'd be easier to figure out where your pipeline fails. And you run it.
That's the answer right there. Keeping this modular means that, yeah, if one of these steps breaks, we don't have to go into our 100 or 1,000 line script. We can just go, oh, it broke before I saw chopping and interleaving files. So, all right. Yeah, my directory paths are wrong. It broke after seeing chopping and interleaving files, but before installing and unpacking seedkit. So I know that this script is the one that's broken, and I can go straight to that file and edit that. This actually, in our case here, like, it would almost make easier time things if we just put it all into a single script, like. We're gonna chop the files, we're gonna download the thing, and then we're gonna run it. But those are 3 steps, and so we're kind of abstracting this, moving those to their own scripts so that we can call them. So I'm trying to teach you the best practice to start with. And so this is in line, I think, with the entire philosophy of Bash in the first place. Think about the tools we've been using, cut, grep. Those only do one thing. They just do it really well. We're putting them together in a pipeline. We're going to try to write scripts that do one little thing, one section of our entire process. And that script handles that. And it does a really good job. And we proofread it and make sure it's working before we move on to the next one. So same sort of thing. Okay, well, this is more or less copy pastable into lesson 5 pipeline.sha, but I want you to look at my directory structure. If you can read that. Kind of hard. So we've got data, and it's got all the files in it. And then in the main directory, it's just lesson 5 pipeline, a readme, and then scripts and data. And inside of scripts, I've got 4 things. And then we've chop, you've got that already. Install seepkit, get stats, and chop files. So if I bring this up. All right, there's my data. Here are my scripts. There's my pipeline in the main directory. Got a currently empty readme. And then this file is, because we were playing around last time, I'll go ahead and remove it. And lesson 5 pipeline is empty. So I'm going to edit that.
We're putting this in our like lesson 5.
Lesson 5 directory. You want your pipeline to be easy to find. You know, you want it kind of next to your README, like, and then your README says like, hey, here's how you run the pipeline, and here's what it's going to do. It's going to call these 3 scripts.
So you wouldn't like recommend making like a pipeline?
Usually there should just be one pipeline.
Okay.
That won't always be the case, and so if you find yourself really wanting to make a pipeline directory, that's between you and your God. You can do it. I won't stop you. It'll work. I just like it to be pretty easy to find. So I'm gonna copy paste. Where are we? There we go. Nope. Here. Copy that into here. Now, if your lesson 5 is actually lesson 05, you should probably fix that there for your main directory. Save that. That's it. Okay. I'm going to look inside my scripts directory. And they are nice and empty. And then leaf chop is there and it's got stuff in it, but the others have nothing. Just made these empty files. What needs to go in them? And keep in mind, you've actually done all of the work that will go into these scripts. All those commands topped off with a nice shebang bin bash and a set UEO pipe fail, and then the commands that you used. And so here, step 1, turn the first part of this lesson, your for loop, into interleave chop, or into chop files sh.
Then would we like are making like this script, like it should always just be in our programs folder. So it can run and then in these kinds of scripts like these pipeline scripts?
No, I'd recommend keeping it in the project you're working on, in the scripts directory. So in our case, we're working on lesson 5, that project. You want the scripts that are part of the pipeline to live inside the scripts subdirectory of that project. The reason is because it's portable that way. If all my scripts lived in my programs directory, and I give somebody my pipeline, they can't actually run it. They don't have access to my programs. But if I give them a folder full of all the scripts they need, then it'll work.
So if I already have like a lesson 5 directory, if I run this script within it, will this like, it'll rewrite everything and like it'll just be, like it'll be fine?
Yeah.
Okay.
So I've done the start of this chop files.sha. And I'm just setting like, oh, here's the main directory. I'm gonna go to that main directory. And then the for loop stuff. So things you did from last time. Do you have a record of them anywhere? If not, why? I don't have a record of mine. My README file is empty. But this is exactly the sort of thing that is handy to add to your README. You get stuff working, you can just store it in there for a little while, turn it into a script, and remove it from your README. And your README can just say, hey, here's the script. So I'm actually gonna have to write this on the fly. Alright, main slash data slash star or files. Here. Here it is. They chop dot sha on what? You can give it forward, the reverse, the out, and the number chop off. So my for loop again is going over what we did last time. Needs to create each of those variables. Oops, and I meant this to be R1. I'm just going to loop through the forward files. Help me out with my parameter expansion. Yes.
Like that. It's equal to the pi,
Yeah,
and then you have to do the weird like the slash to replace it.
so whenever I see R1 in that variable expanded, change it to R2. Sure. And then out.
It's like the double mod, every double percent. Underscore stars. It's the chop fast view. I have echo of the that file name. And then
And then N is we chopped off 200. Okay, so we got our forward reads right here. That's what we're looping through in the first place. We're assigning the complementary reverse read the same file name, just with R2 instead of R1. And then the out will be just that first little bit. It will chop it off on the longest instance of underscore and then anything. And that gives us like S of 90. And then we're going to append an underscore chop.fastq to that. So that'll be our out file. And then N will be 200. Done. I'm happy with this. I like it. Of course, it could not work because I'm missing something, but yeah, screw it. Save.
Is this the, they're already, oh, I guess you're just making new chopped files, but because
They're already there. Yeah, so we're gonna remove them first, but we wouldn't have to. It'll just overwrite them.
oh,
I'm gonna remove them first so that we can see that this actually worked. Okay. So I've made chop files.sh. I'm excited. I need install ckit.sh. Bang, bin, bash, set, ueo, dash ueo, type, fail. And then what?
you got the DH.
This shit right here. But it's not quite so pretty. I don't like the underscore programs is hard coded in exactly like them. It'll work. But okay. But really, that's pretty much the whole script. Copy that. Paste it in.
You have to remove the into
What's that?
you would remove the tar fault too, or
Yeah, let's do that. Clean up after ourselves. Do the dishes after dinner. When CKit showed up, did it come already executable? Or did we have to do that?
it's adding to the
So it should be in our path already. Because we did it, the programs and programs is in our path. And because seed kit is just a single file that lives there, we'll be okay. If it was in a subdirectory, we would definitely have to add that to the path, and we would do that by, I don't know, export path equals the path and then new path to wherever. But we don't need to do that in this case.
What is the export?
It's the proper way of setting a variable that already exists. And so I could just say path equals, but it's less safe since path is a like built-in variable.
Yeah.
It's nicer to say export this variable name. So I think, yes,
You don't have to like associate with actually I see.
we don't have to in this case because programs is already in our bash RC. But you're right, for like fly, that program I showed you, we would need to add a line here that adds it to our path in the bash RC. And we could do that by saying echo export path equals current value of path followed by programs fly bin, for example. Put all that in quotes and then send it, not overwriting, but appending to home.bashrc. That makes sense? That would just send that whole line right to your bash RC, so you don't have to manually type it out when you run the script as it. Of course, it's not yet part of your path just because you put it in that. You have to like shut down and restart, or you could just say source home.bashrc, and that'll run the whole bash RC script.
So really, I noticed I was like trying to do the assignment, it was like every time I did like this source that accuracy, the path still wouldn't work, it only worked if I just like played and reopened it. Is that normal?
Yeah, I have.
Really?
Oh, no, on both at least.
On Laura. That sounds like a Bora thing. Okay. In which case, forget what I just said. And you would say exec bash, that's the just restart. Resets your whole bash and runs that script. Equivalent to closing it and reopening.
You have to say that after like. doing-
After adding, yeah, so suddenly now bash RC has this line in it. And then exec bash would run the whole thing, including that new line. But our current script here doesn't need any of this nonsense. We're just gonna install this into programs, unpack it, and then clean up our mess. But I think there's one last thing that we need to think about. Permission. Chmod plus X. Seedkit. And I think that's just the name of it. It didn't have any file extension or anything, so.
When it has the asterisk after it, do you then put that in or is that just like?
No, that's just like letting you know that it's an executable.
Okay.
So it'll turn green and have an asterisk.
Yeah.
The asterisk is there in case people don't have colors enabled.
Okay. No, mine are just green. Yeah.
You're just green.
Yeah. Okay.
Cool. I don't know what's going on. Yeah. So we've got different profiles set up. Okay. Now, if we run this script, where will we be at the end?
Still.
Yeah, we're still in programs. So our overall pipeline will have to keep that in mind. that after this script runs, everything currently is in programs and it'll do somewhere else. That's okay. I'm gonna save this. All right. And then we need a third one. Third part of this lesson, turn that into getstats.sh. And really what that did was ran seek-kit stats on star.fastq in our home lessons, lesson 5 data directory. Okay. Nano, get stats, shebang, bin bash, set dash upo type fail. What should this script do?
You should take you back to your main directory.
Okay.
So,
CD, well, let's set up a variable just to be explicit. Here equals from A, biocomputing lessons, lesson 5. Say, go to the main here we just created. Okay. So is it really this simple? Seek-kit stats star.fastq. No,
it's a CD to the data directory.
if we ran this, it would say nothing. It's like I don't see any files called fastq, so I'm gonna have to do /data. I could have done a CD into the data, and then it would have worked. Or do it this way. In any case, it doesn't really matter because all those stats, they're not going to a file. They're just popping up to the screen. It's a little sanity check for us.
This, maybe don't, but if we're using a lot of the same names for variables, it only, like, those given values only exist within the script, right?
It exists within any session.
So like, if we were to say like new directory in here and give it like whatever, and then in another script say a different thing.
It would override it with the new.
Okay.
Yeah,
That's what I like the latest.
it's the latest one, yeah. It's not a dumb question.
Here the output in our,
The output,
like what you said.
yeah, it just pops to the screen, and the screen, and this is kind of counterintuitive, doesn't actually exist in any directory. It's that has messed me up for like years until I finally realized like, oh, the screen that I'm seeing doesn't actually exist in a directory. It's separate, it's the standard out. So yeah, it's just gonna pop to the screen no matter where you are. All right. So I think that is actually this simple. Save that. Yes. No, you don't. Wait, mine RDR because I already did. But yes. So chmod plus x star. What's that gonna do?
I think everything.
Everything inside of this directory executable. So a little shortcut for you. Wildcards are nice. mean, you wouldn't want to do that for a text file. So you could say star.sh if you wanted to limit it to just your bash scripts. Okay. So now I've got my pipeline that's gonna call those scripts. They're gonna be accessing the data. So I'm gonna go and remove the chopped files from my data. Go into data and give me a command that'll remove all of them at once.
Do rm star chop star.
Yeah, that should be safe. None of my actual raw data files here have the word chopped in them. Okay, I'm back to the basics. I've got my raw data. Go up. It'll override it. Yeah. But we might as well, you're right. I like that. CD into my programs. Remove seek kit. Okay, it's gone. CD biocomputing lessons, lesson 5. Now I'm back. Okay, seek kit is gone. My pipeline, it's executable. Go ahead and give yourself that permission. The moment of truth. I'm just gonna hit enter and it's gonna see what happens here. I hope that I wrote the scripts right. Doesn't look right. Happened. Looks like we got CKit, okay. It ran. So that script worked really well. Chopping and interleaving files. If I go into data and just look around, I don't see my chop files. So the fun part, let's troubleshoot. Where do I go? Troubleshoot this.
Or what is there? What was your line?
There wasn't an error.
That would fine.
There's something like no filing.
I got chopping and interleaving files. That's the echo. And the next thing I see is that. So it didn't throw an error. We made this modular though, so it helps us when tracking down the problem. Our chop files script is the first place I'd start looking. So I go into my scripts and chop. Okay, scripts, chop files. It looks right to me. Go to that lesson 5 directory, and then in there, go for data, star R1, star fast Q, and then we set up our variables. How can I test it? Let's just call it on its own. I'm gonna say here, shop files. It ran, whatever that means. So I'm gonna look back one and then up into data. It did not run correctly. You know, but
It's look like the. Training.
it won't change anything, but you're right, it's better practice. Keep them safe. I'll do the same for these, just to make it look pretty. What to do, what to do. No, because we're calling it, you mean like the chop files or that? We're calling this here. I can use this real path. Interleave chop, and it's, so this is where it lives. Lesson 5 script interleave chop dot show. Okay, so that seems right. So nano chop files. So there's a problem here in this script, I'm thinking. How do we troubleshoot it? We tried running the script and it just gave us nothing. Now it's time to go through it one line at a time. So the easiest way to do that is to cat chop files, so we can just copy paste. So I'm gonna start with this line here. Cool. Go to main here, copy paste. Here's my for loop. Paste it in. Still didn't freaking work, huh? Well, I've hit up a couple times and I've got my for loop now all in this one. So let's add in some diagnostics using echo. So we set our forward, we set our reverse, we set out, and Now, I genuinely don't know what's going on here, but notice that each of our little commands ends with semicolon. Except for this one. Hmm. By nano, oops. Scripts, nano, shop files. Well, let's add some diagnostics. Echo, forward, reverse, out, and. All right, so as it's looping through, instead of running in a black box in the background, it's at least going to tell us what our variable names are. That'll help us diagnose. Run it again, shop files. All right. There's my forward. There's my reverse. There's my output. And see a problem? What? Lesson underscore chopped, and look at that, it's just every time. All of them are called lesson chopped, and they're in my lessons directory. So if I go up, there it is. Lesson chopped. All right, what the hell happened?
I guess we need some integrated products. Pulling out the.
It is, so. We go down. CD scripts. All right, so I'm gonna run chop files again just so I can get those back up. There's our first one. Or let's just add chop file so we can look at this. All right. So that's our forward. Right here. And then it's getting the reverse. I like the look of that. That's looking pretty. And then the out is just called lesson chopped. So there's our problem. So our parameter expansion is giving us something we didn't expect. So let's look at it. It's taking our forward, finding the longest instance of underscore star. Here's our forward. The longest instance of underscore star starting from the back is not S099, it's lesson. Okay, can we fix it? You don't know? Okay, you're right, it's unfixable. There is, it can't be done. Or wait, maybe it can. Yeah,
I think when we assign the main directory variable, we need to go.
we could do that. So if we go into data, we wouldn't have lesson 5 be part of the thing, it would be the data here.
Cause in our, like I have one saved from last time, and it said for I and like /data. I don't know if that.
Well, that's kind of, that's, I mean, that's where we are, yeah.
Yeah.
We'd still be dot slash since we went there. So what you're saying is take this part here. And just change it to a dot.
I mean, I don't know if it'll fix it, but that's just what we do.
And that'll work because we're already there in the directory. Okay, well, you came up, I think that'll fix it. But I was not expecting anyone to come up with that solution, damn it. I was gonna make us fix this part. Alright, real slick. You ruined my lesson, but that's a better fix than what I was thinking of. The fix that I was thinking of was, we're gonna have to take this and find a way to get rid of the underscore there inside of this. Which wouldn't be too hard, because we would just set a new variable called temp. And we would remove the first underscore, and that would fix it, and out would be temp percent instead of forward. But I like yours better. And I feel stupid now. So let's fix it. So I'm gonna nano chop files. And since I'm already CDing into main gear, I don't need to do that. I can just say, hey, I'm there already. For I in data. Okay. Yeah. So I could do temp equals forward and then look for lesson 5 and replace with lesson 5. Like that. And then this would be, yeah. Okay, but I don't know. I think honestly that's gonna work. Getting rid of having the whole file path there. So I'm gonna try it. Chop files. Look at that. That's beautiful. So if I go into data, I should see those chop files. There they are. Now I'm gonna destroy them. Move star chop star. I'm gonna go up. And I think I'm ready. Having now found and isolated and fixed the problem in that one script, we can just go right back to the lesson 5 pipeline. It ran everything and spit it all out here, and I am happy with it. Are you happy? We could have just put 200 there in the for loop instead of ending with 200. I just like setting variables at the top so it's easy to like end in one spot. We had a bunch of steps. We wanted it to all be the same. We just call in for all those and then we have to change it in one place. But you're right. We accomplish the same thing either way. All right, talk to me about what we just did. Are you encountering errors? What parts are kind of muddy in your head right now?
So, chop files, cases.
So you got data star. So let's look at your chop files. recommend for reverse and out. And data slash. Yeah. Alright. Other problems? Successes all around? Alright. Does it feel easy and a bit stupid?
I would say it
Yeah,
was
what-
easy.
Alright.
Let's say.
How about simple
So-
in terms of like concepts? It's not. It can be, yeah. So then again, like we messed up a little bit there and troubleshooting that was took some stuff, right? But it made it a lot easier since our scripts were all separated. We're like, oh, it's happening in the chop files script. Let's look at that. I don't see what the problem is. Let's try running it by itself. Not getting the right answer, so let's do it line by line. Oh, I don't know what's happening still. Let's add an echo diagnostic so we can see what's going on behind the scenes. And that's when we solve it. So that's the process of troubleshooting that is going to happen every time. It's what's wrong? I don't know what's happening. Let's look at our script and oh, I forgot a slash. Oh, there's a comma here. I put a space after the equals, just little things like that. But I think from a like broad perspective, bird's eye view of what we're doing, ain't rocket science. We had 3 simple little scripts. Yeah, they're hard to get right, but once they get right, you're just calling them one at a time with the master script. That's it. So what's left for your journey of becoming a bioinformatics guru? Everything,
Yeah.
right?
Nice.
The answer is everything, but like it's also just more of the same, honestly. There's one final step that we haven't done yet, and that's talking to the supercomputer and requesting resources. Right now, we've been running everything on the login node. That's only possible because we have fake data. These real data sets were each at least, 50 megabytes. It take longer than 30 seconds to run, big problems. So once we can tell the supercomputer, hi, I've got a pipeline I'd like you to run. Here's how much time I want. Here's how much memory. Here's how many cores. Please run it. That's seriously the only missing puzzle piece, and you're a bioinformatics expert, just with low experience level. That's it. And then it's just more of the same. We're taking other people's programs and little scripts we wrote ourselves in order. We're running them. That's a pipeline.
I don't know if you mentioned this earlier, but like, is there a way you can like make variables that you can call within the other scripts? Like if I say like, I have like this main like variable, like and this is like my path that like I know works in my other scripts, and I still call that main variable, or is that only, we call
Within
variables?
each script.
Yeah,
Yeah, if you set an environment variable in your main pipeline script up at the top, then any script that runs after it will be able to access that environment variable.
okay, so we didn't need to like set main again every time.
No.
We just
Sure did.
call it.
We could call it at the top of our pipeline. You can see that's what I actually did. So we were doing it inside of the scripts, but we didn't need to. So the pipeline goes into the scripts directory, runs chop files. Goes into the install directory to install ckit. But the install ckit script is actually in our scripts directory. So although we're going to be inside of the install directory, we're running that script from the scripts directory. Going into data here. Yeah. So this is how I most commonly see good pipelines done. I see a bunch of shitty pipelines out in the world too, but they're fragile. The good ones set everything up at the top like this. Here's my pipeline, here's the directories I'm gonna be working in. And so I can just call them. But I want you to feel good about yourselves, give yourselves a pat on the back. Go home, crack a beer, whatever it is you need to celebrate. That you have now composed and actually run a bioinformatics pipeline, however stupid it might have been, doing stuff we didn't care to do. But you've done it on a high performance computing cluster. That's pretty cool. Yippee. So next up, we've got assignment 4 due next class period. 5. Yes. Thank you. Assignment, let's make sure. No, I'm not going mad.
This board is, yes.
Yeah, okay, I just haven't graded it yet, so I forgot. And look at what your assignment is doing. Making a pipeline. Okay. So one extra little hitch is that your script is actually gonna have to do the downloading of the data. Your script is then gonna install a tool called FastP. Well, a separate script is gonna do that. And then a script will run FastP. And then you're gonna have a master pipeline that does all 3 of those scripts. So basically exactly what you've done already. And then push to GitHub. Yeah.
Yes, I heard it, like all the members that we do have that.
Yeah, so let's see. You want it to work on a single sample. Okay. And it runs FastP on each. Where'd we go? So it gives you like diagnostic stuff and can trim your stuff way better than the whole script I wrote. And so you need to give it input and output, tell it what to trim. Okay. Are you wondering if you have to put all of these parameters? If you like the default, like here, the end base limit default is 0. If you're fine with that, you don't have to put that in there. I can't remember what I told you to make it do. Oh, with the settings, oh, yeah, I'm making you do all of these. So it'll be a nice long command. Yeah, it's gonna wrap across like 3 lines probably. So we're trimming the front 8 base pairs of the forward and reverse read, front 1 and front 2. And then the last 20 from both of those, we're throwing out any reads that have an in them. Throwing out any reads that aren't at least 100, or that the average quality score isn't at least 20. Then you've got to provide the output 1 and 2 and the input 1 and 2. Path to HTML report, you know what, let's just send that to DevNull also. DevNull is, remember, one of those imaginary files that just means cast into oblivion forever. If you send something with the redirect to root DevNull, it just disappears. Cause this makes you define a file output for the JSON and the HTML, but those are just big, ugly, bloated, horrible things. So we're giving it a file to go to, it's just oblivion. Neat. Okay. So the next quiz Thursday and this assignment done. I'll try to have the assignment 4 graded by this afternoon. Any questions? Yeah.
The next question is six, and I'm like confusing like what the topics are right now. Is it gonna do like more, mostly like on like the graph stuff? Cause that was like last week, and then like this week or next week would be like more like the pipeline.
I just looked at it this morning,
Okay.
anticipating this question
Oh.
and totally forgot.
Okay.
Yeah, let me stop recording here.